Okay, so the next part of this lesson is writing the algebraic reflection. So again, this time I have f at x is 2x plus 1, and they want me to reflect it into negative x at x. So what they're expecting me to do is to reflect it into the x-axis. So the way we do this as far as it goes is we're going to multiply the entire expression by negative 1. Now, the reason we're doing that is recall that when we're talking about the reflection, oops, disappeared on me. We're talking about the reflection of the points, remember, x, y, and so this reflection is going to change the y value. So we're reflecting, so it'd be x to the negative y. So if I multiply the entire expression by negative 1, so when I'm looking at then negative f at x, what happens there is I'm taking that entire expression, which is x squared plus 1, and I'm multiplying it by negative 1. So I'm multiplying it by negative in front. So when I do that, I end up with a negative 2x minus 1. So that becomes the algebraic reflection of that. So you could, in a sense, calculate the algebraic reflection and then use that to graph rather than just graphing individual points. Now the next one asks us to reflect into the y-axis. Okay, so it has g, we want g at negative x. So what we do here is we just replace the x with negative x in the expression. So again, what we do is we're taking, normally we would take all the points and we would go, don't you just love how that moves wherever it wants to? X, Y, and we are then reflecting it, so it's going to be negative X, Y. So it's based on that. So G at negative X becomes 5 bracket negative X minus 1 squared minus 4. Okay, and you leave it like that. Okay, so it looks messier than original, but we leave it like that. And again, we could graph from that position as well. And if we look at the last algebraic inverse, this time I haven't put what we want us to do. So this time we want to take h at x and we're going to do an algebraic of negative h at negative x. We'll see what that looks like. So when we're doing this one, we're reflecting it into both axes, so kind of like that origin reflection. So the first thing we're going to do is we're going to replace x with negative x, just like we did in part B, and then we're going to multiply the entire expression by negative 1. So again, really not that difficult, okay, because remember it is both the x and y that become negative. So negative h at negative x equals negative, the whole function is going to be multiplied by that negative 1 over negative x, because I have to replace the x with a negative x, minus 6. Now this one we can go a little bit further. So we're going to expand that negative 1 into the bracket. So this would be negative 1 over negative x plus 6. And a negative over a negative becomes a positive. So we end up with 1 over x plus 6. Okay, so if you can expand, please expand. Make sure you reduce any double negatives as well. Okay, so what you can do is you can spend some time working with graphing the reflections as well as the algebraic equations of these reflections as well.